We'll start class. Last class, what we have discussed? Do you remember anything?
Syllabus, ma'am. Syllabus.
And overview of the subject, right?
CEOs.
Those outcomes and about the syllabus. And just we compare what is microprocessor and Dspa processor. And do you remember what are the major features of DSP processor? Major features. What makes DSP processor so special compared to your microprocessor?
I know it's photos.
No photos. I want to share PPT. Yeah? Then only you can answer.
No, ma'am. Pranay has notes. He's writing. He'll send photos. We'll answer.
Very good. Very good. So DSPA processor has 4 special features. Last class we have discussed. A separate math unit, multiply and accumulate unit, and no overhead looping, zero overhead looping, and specialized addressing modes. Okay. So those are the features of DSPA processor. Now we will start the syllabus. The first unit, which is number formats used for DSP system. Is it visible?
Yes, ma'am.
Okay. So we'll start with the number formats. I think you know number formats and you have studied several number formats, right? In which subject you have studied number formats? Which subject you have studied number formats? Numbers. Tell me your lucky number, all of you. Lucky number.
7.
7.
3.
Okay.
9, ma'am.
Okay. 0 to 9 maybe. Let's take 7. How to represent 7 in binary?
Triple one.
Binary. 0?
111.
0, 111, right? So what is the number system you are using? Binary number system, right? But in daily life we are dealing with only decimal number systems. So in which subject you have studied these number systems?
Digital electronics.
Digital electronics. Studied, right? So total world is simply using only integer values, but every programming language supports numbers where that numbers can be represented with either binary format or octal format or hexadecimal, and you know different types of number systems, right? What are the number systems? Binary, octal format, hexadecimal format, right? So any number can be represented with those number formats. But every programming language supports number formats. If you consider microprocessor, you are familiar with microprocessor, right? So what type of number system is supported by the microprocessor? Can anyone tell?
Binary number system.
No.
Hexadecimal.
Hexadecimal. You are not writing program in terms of zeros and ones, right? You are writing every input.
Machine language.
If you want to take, not machine language, it is hexadecimal. That will be converted into machine language by the assembler, right? You are writing program in the assembly language or not? Hexadecimal lone kada మనం రాసేది. So microprocessor supports only hexadecimal number system. Hexadecimal means how to represent hexadecimal number format? 0 to 9 normal. For 10, what is the symbol?
A.
For 15?
F.
F. So simply hexadecimal number system is supported by the microprocessor. Similarly, DSP processor supports 2 number formats. Those are fixed point format and floating point format. Already you know. Generally, we are using binary number systems, right? That is nothing but simply fixed point format. So your first unit contains only 2 topics, major topics. One is what type of number formats dealing with the DSP systems, and second one is what are the errors occurs in the DSP system. These 2 topics only. So today we are going to discuss the number formats. So DSP supports 2 types of number formats. One is fixed point number format, one more is floating point number format. And in fixed point format, there are 2 types, signed integers and signed fractions. If you consider any numbers, we have integer value as well as fractional value, right? You know integer value and you know fractional value. So our last class we have seen these ICs. Can you name the company names of the ICs?
Texas Instruments,
First one
Motorola.
is Texas Instruments. Second one is,
Analog devices.
what is second one? This one.
Motorola.
Okay. And what about this third one? Analog devices. Right? Now, if you consider these 3 ICs, see, Texas Instruments, suppose if you consider 320C XX, this IC, This IC supports only 16-bit fixed point format number systems. Listen, we are not giving numbers in floating point or fixed point by external. మన నార్మల్గా కీస్ ఎలా ఇస్తాము ఆ ఇన్పుట్ ఎలా ఇస్తాము డెసిమల్లోనే ఇస్తాం. Internally that process converts your input into that format. That may be either fixed or floating. అది ఏ ఫార్మాట్ అయితే సపోర్ట్ చేస్తుందో that format will be taken by the processor, right? Even for your microprocessor lab also, you are entering only keyboard characters, right? A, B, C. That value is converted into again hexadecimal value by the internal process assembler. Is it okay? So these processors, suppose if you take TMS 320CXX, it supports only 16-bit fixed point. And one more series is there, that is 32-bit floating point. And similarly, analog devices, one more company is there, so it supports 16-bit floating as well as 32-bit fixed point and floating point. And Motorola. So these are the various manufacturers of ICs and which supports a fixed point as well as floating point. Power, no need to use mask right now. Okay.
Show a
Now Lucent Technologies. This is one more manufacturer which produces DSP processor. It is also supports fixed and floating point. So from this PPT, the overview is all DSP processors supports the number formats only fixed point and floating point. Already we know fixed point. We have studied also, but we don't know that name fixed point. Okay, can anyone tell what is fixed point?
It is like binary system.
Binary system is very good. Binary system is example for fixed point. Can anyone tell 5.625? What is a binary representation? 5.625 value, decimal value. How to represent in the binary? First tell me for 5.
101.
Add with 2.
Huh?
108.
5 ki binary representation.
0101.
Ma'am, 0,
If you
0.
take 4 bit 0101, otherwise 101, right? That is for 5. What about 0.625? How to represent 0.625?
That too.
Value, binary. 0.625. Otherwise, tell me the procedure. How to calculate 0.625 binary representation?
Usual, man.
You are very much knowing about the E.
For 2, 0100.
Up to?
5, 0100.
Yeah, do it and tell me answer. All of you give your answer in chat box. I want to check first. Yeah, make it fast. What is a 0.625 value? I don't want 5, only 0.625.
2 వేయాలి మేడం.
Send me in chat box. Yeah, who is? Audio is mute. 401. Not audible, huh? Okay. 407 gave answer, but it is wrong answer. 0.625. E2, very good. 4E2 gave correct answer.
Thanks, ma'am.
Inka, still I want answers. 4E2 gave correct answer.
ఆప్షన్స్ లేవా మేడం?
Ma'am, point తర్వాత multiply చేయాలి. Okay. Yeah, 16 right. But what is the answer? Binary representation. In 4th year, you have to write gate exams. 0.625 multiplicate binary value. I'm seeing answers. Okay, ma'am. What is the answer? 0.101. For 0.625, the binary representation is 0.101 or not?
మేడం చెప్పండి.
0.101. How? I'll explain. So see the topic first. So this is fixed point format. So first we are discussing about fixed point format. So simply fixed point format is nothing but your binary integer arithmetic. Okay. General life we are using binary representation, right? That means in the E subject we are dealing with binary, right? So simply if you consider any decimal point, Suppose I am taking 192 plus 37. What is the answer? 229. Is it integer or fraction? Only integer, right? This value I am taking two integers and addition also gives only integer value. This is called fixed point integer. Suppose if you consider one number which contains both integer as well as fraction. I am taking the number same 5.625. In x is nothing but 5 and y is nothing but 0.625. So x is I am saying as integer and y is I am saying as fraction, right? So how you are differentiating which is integer and which is fraction? Depending on this binary implied point or not, this point. This dot is there, right? So the value towards the right side of your dot or decimal point is said to be fraction, and the value right side of your decimal point is, sorry, left side of your decimal point is said to be integer. Is it or not? 5.625 means 5 is the integer and 0.625 is the fractional value. Now, in case of your binary, see, binary is nothing but fixed point. This is the binary implied point. Okay. Now I am representing 5. 5 means what is the representation?
Zero.
I have to write okay. 5 means 0, 1, 0, 1, right? 0, 1, 0. That means last bit is B0 bit is 1, next B1 bit is 0, and this is 1. 1, 0, 1 or not. So binary implied point is here. How to calculate 5? 1 into 2 power 0, 1 into, sorry, 0 into 2 power 1 and 1 into 2 power 2. 2 power 2 is 4 plus 1, that is 5. Similarly, how to calculate the fraction value? This is the fractional representation. Here binary implied point is there and towards the right side is a fractional value. Now what I said, for 0.625 the value is 101 only. Now multiply this b minus 1 and this digit will be multiplied with 2 power minus 1 or not? 0.101, all of you note down 0.101. First one is multiplied with 2 power minus 1, then plus 0 is multiplied with 2 power minus 2, plus 1 is multiplied with 2 power minus 3. First one empty 1 into 2 power minus 1, simply 1 by 2 ena. 1 by 2 is nothing but 0.5 or not? 0.5 plus second term is 0. 0 into something, so it is 0, 0.5 plus 0 plus 1 into 2 power minus 3. 2 power minus 3 is nothing but 1 by 8 or not? 1 by 8 value how much? 0.125. 0.5 plus 0.125 how much? 0.625 or not? Is it or
Okay,
not?
ma'am. Okay.
This is after, if you know, after knowing the binary, how to get the decimal value. If you know the decimal value, how to get binary value? Simply multiplying with 2. 0.625 into 2. What is the resultant
Yes,
value?
ma'am.
Take one
I
aside and take the remaining fraction. Again multiply with 2. Take the value. Okay. That is the representation of binary. Is it clear? So basic your binary implied point differentiates which is integer part and which is fractional part. You know this one and you have done several problems also.
Ma'am.
Nothing new, right? It already తెలిసిందే కదా.
తెలిసిందే మేడం.
Same thing, this is the representation. Is it clear? If I consider n weights, I am starting with 0th bit, right? So what is the MSB bit? N minus 1. This is general numbers. But here the heading, see, what is the heading? Signed numbers. Signed numbers means what? Along with your numbers, I am indicating what type of number it is, whether it is a positive number or negative number. So this indicating with the significant, sign bit S. So tell me for positive number, what will be the sign bit, whether it is 0 or 1? For positive number, sign bit should be 0 or 1. Microprocessor,
Zero.
programming user, positive. Okay, okay. Who said answer right? For positive number, the sign bit is 0. For negative number, the sign bit is
1.
we are representing binary means we have only two values 0 and 1. For positive number the sign bit is 0 and for negative number the sign bit is 1, right? So this is the signed number representation for integers as well as fractions. Is it clear? Is it clear for everyone?
Yes, ma'am.
Yeah, give response, ma. Right? Now, same. Already we have discussed how to represent the value. So this is for integer part. Integer means left side to the binary implied point. So it is simply b0 into 2 power 0, b1 into 2 power 1 and b2 into 2 power 1 and so on. And sign bit is also we are considering, but sign bit should not be multiplied. Just sign bit will be keep aside. Okay. This is the equivalent value to get the signed integer. So see, S0 represents the positive number and S equal to 1 represents the negative number. And what is the range of numbers that can be represented with this format is, this is very important, minus 2 power n minus 1 to plus 2 power n minus 1 to minus 1. This is the range. All of you note down. You have poll questions as well as assessment based on this topic. So note down the range. You have to answer later. Note it down. The range of signed numbers. Okay. Minus 2 power n minus 1 to 2 power n minus 1 minus 1. This is a representation in the range. Completed. Next, similarly signed fractions. So how to multiply this, how to get the fractional equivalent value? First bit into 2 power minus 1, second bit into 2 power minus 2 and so on. And no need to consider here sign bit. Simply sign bit is 0 means positive and 1 means negative number. And just note on this also. Range of signed fraction values. If you represent the numbers with the fractions, what is the range? Minus 1 to plus 1 minus 2 power minus n minus 1. All of you note down the range for signed integers and fractions. Over. Now, yeah. Answer this question. What is the range of numbers that can be represented in a fixed point format using 16 bits if the numbers are treated as signed integers and signed fractions? So n is given as how much?
16.
16. So range of signed numbers. So already we know the range formula. So substitute n equal to 16. It becomes minus 2 power 15 to plus 2 power 15 minus 1. So 2 power 15 value is 32,768. Minus 1 becomes 32,767. So total range of numbers using 16 bits you can represent, this is signed, that's why you got negative numbers as well as positive numbers. Other signed number won't be 32,768, right? So minus 32,768 to plus 32,767. Is it clear? This is the range of signed integers. And what about the fractions with the 16 bits? So fractions range is minus 1 to plus 1 minus 2 power minus of n minus 1. So just substitute minus 1 to 1 minus 2 power minus 15. 2 power minus 15 is nothing but 1 by 32,768. So the value is this much. So the range of fractions is, you can represent the fraction value from minus 1 to plus 0.99969,482. This is the range of fractions. Is it clear? Now answer my question. If n equal to 4, what is the range of signed integers? If n equal to 4, range of signed integers. Is everyone is there or not? You can give your answers in chat box, otherwise you can.
Minus 8 to 7, madam.
Minus 8 to plus 7. This is sign, no? So you have to mention minus and plus. N equal to 4. 4 minus 1 how much? 3. 2 power 3 is nothing but 8. Minus 8 to plus 7. Right? Now, is it clear? Now, if I want to multiply two numbers, just listen. This is about fixed point fractions as well as integers, it has one drawback that is known as wrap around. Okay, so wrap around is nothing but it generates most negative number after most positive number and vice versa. And vice versa means most positive number will be generated after most negative number. Now you said for n equal to 4 bits, what is the range? -8 to +7. So if you write the numbers -8 to +7, what is the number next to the +7? +7 తర్వాత వచ్చే number ఏంటి? In the range, you have mentioned the range -8 to +7. -8 to +7 అంటే -8, -7 and so on, 0, next 1, 2, 3, 4, 5, 6, 7, right? After 7, what is the value you got?
-8, madam.
-8, only within the range, just observe. So -8. And similarly, after -8, what is the number you are getting? +7, right? Are you getting or not? Total range is -8 to +7. After 7, you should go with the -8, and after -8, you should go with the, that means beyond -8, you should go with the +7 or not, right? So that means if you are multiplying two numbers, suppose I am multiplying two integers, but my result exceeds the +7. Exceeds the +7 means you have to give the answer either 7, either correct answer, otherwise maximum, highest value, right? Is it or not? G3, you have any doubt? 4G3. Okay, now I have multiplied two numbers whose result is greater than +7. But what I am getting the result after +7, it shows the value -8. So that is a statement. It generates most negative number after the most positive number, right? So that is said to be wrap around. Similarly, negative number also. Yes, some people raise your hand. Is there any doubt or you want to say something? Okay, after -8 also, I want to get +7. So I want to get least negative number, suppose -10 or -9. But what I'm getting +7. So this effect is called wrap around. So simply wrap around is nothing but generating the most negative number after the most positive number, otherwise most positive number after the most negative number. This happens only with the signed integer values. Similarly, you take fractional value 0.101 into 0.101. What will be the resultant? Resultant will be exceeds the original value or resultant will be less than the original value. 0.625 into 0.625 value into similarly. It will be less than the 0.625 or not, fractions value. So simply by neglecting the least digits, LSB bits, you can get the answer or not. But in case of integers, it is not so, right? So this problem wrap around is especially comes with the integer values. So this is the drawback of the signed fractions, sorry, fixed point format, right? So just note down wrap around, which generates the most negative number after most positive number. Now to overcome this drawback, we go for double precision fixed point format. So previous wrap around drawback is due to what? The range of numbers or not. If you increase the range of numbers, then we can overcome the wrap around effect or not. So how to increase the range? How to increase the range? If you increase the size, then we can increase the range or not. So simply if your size is doubled, then it is said to be double precision fixed point format. If you are using only, previously said to be single precision fixed point format. Now I am the size will be double, so it is said to be double precision fixed point format. Okay, but what is the drawback of this double precision fixed point is it requires the double the storage of the same data, and it requires 2 times of accessing the same data or not. It requires 2 times of accessing from the data bus and requires the double the storage of the same data. Okay. To overcome the wrap around, we gone for double precision. But double precision is nothing but simply doubling the size so that you can have more memory and so that you can have the more number of accesses from the data bus. So these are the points regarding double precision fixed point format. So up to now what we have discussed, fixed point format which contains signed integers and signed fractions. It has one drawback. What is that? What is the drawback?
Wrap around.
Wrap around, right? So to overcome that, we gone for double precision, but double precision requires storage as well as accessing. Okay, we don't get any calculation error, but it requires a storage and accessing. So the next important thing is format is floating point format. To overcome the drawbacks of fixed point format, we go on for floating point format. See the representation, this is very important. Any number that I am taking number x, this x is represented like this. So the floating point number is made up of three components actually. One sign bit, mantissa and exponent. So this exponent indicates your integer value. Previous we have decimal point, left side of your decimal point represents integer and right side of your decimal point represents fraction, right? Similar to that, here the fractional value is represented with the mantissa. Okay, and your integer value is represented with the exponent. There is a standard format for floating point which supports your DSP processor, that is IEEE 754 format. See total how many number of bits are there in this format? Count all of you. How many bits are there? 28 plus 8, sorry, 23 plus 8 plus 1, how much?
32.
Answers.
32, ma'am.
Only Pavan is giving answers, no one answering.
32, ma'am.
32, right? Still.
నేనే చెప్తున్నా మ్యామ్.
Okay, ma'am. So total 32 bits. Among 32 bits, one bit is assigned for sign bit. Similar here also same thing. For positive number, what is the sign bit? 0. For negative number, sign bit is 1, right? And exponent bits occupies 8 bits. So this 8 bits indicates your integer value. And 23 bits are assigned for your fractional part, which is mantissa. So this mantissa indicates the fractional value. Single 32 bits. Okay, among 32 bits, three components are there: sign bit, exponent, mantissa. Exponent indicates integer, mantissa indicates fractional part, and sign bit indicates type of number, whether it is positive or negative. Now I am taking two numbers. Like two numbers are taking x and y. I want to multiply these two numbers. So what will be the equation? Mantissa of first number into mantissa of second number. Similarly, 2 power ex and 2 power ey. So what are the operations involved here? Mx into my. I want to perform this one. What type of architecture I need? Multiplication cheyalante em architecture కావాలి? Options? You want options?
Yes, ma'am.
Okay, first option is shifter, second option is adder, third one is multiplier, and fourth one is subtractor. To perform mx into my, what type of architecture you need?
Multiplier.
No doubt it is multiplier.
So correct it now.
Adder.
Adder, no, ma. Mx into my means what type of mathematical operation it is involved? Multiplier, right? So simply you need a multiplier architecture. Okay, now tell me, you are very intelligent. I think you need to answer this question. 2 into e power x and 2 into e power y is there. What type of architecture you need here? Only first tell me how to simplify this expression. 2 into e power x is there and 2 into e power y is there. All of you see this one. This one. How to write this one? What is the next mathematical simplification for this one?
2 power ex plus 2 power ey.
Of ax plus ay.
2 power ex plus ey.
2 power ex.
E of x plus y, ma'am.
Why you have added those two exponents? Because the base is common, right?
Common.
Right? Okay. Now what type of architecture you need required?
Addition.
Addition. Remember,
Addition.
just leave
Add.
about the base. Exponent should be added, right? That means mantissa should be multiplied and your exponent value should be added.
Added.
Base is same, so
Base
both
will be
be
same.
added.
That is said to be normalized. Base common ga unnappudu you can add the exponent values, right? So that process is said to be normalization. Okay. Now, and how to represent the value. This is about what type of architecture you require for floating point format and how the value will be represented and what is the format. Now, how the value, that means if you consider one number, how to represent the number. These are very, very important points. All of you note down because your poll questions as well as assessment today depends on these only. Note on this also. The range of fractional numbers with IEEE 754 format is the range. And you need to do one problem based on these parameters. Fractional numbers range is minus of 2 minus 2 power minus n2 plus of 2 minus 2 power minus n.
మళ్ళీ రిపీట్ చేయండి మేడం ఒకసారి.
What I have to repeat? Equation. You are not seeing screen, huh?
మంది ఏం చూస్తాను
Varun,
సినిమా చూస్తానవా
72 Varuna.
మంది పండు
మొత్తం పవన్ గెలుకుతుండు మమ్మీడ ఊకే మెసేజ్ పెట్టి చంపుతుండు.
మేడం నాకు వాట్సాప్ లేదు.
గూగుల్
Note
తీసిన
down, note down. First note down. You have assessment test. Quickly note down. Screenshot. Completed?
ఎస్ మ్యామ్.
అయిపోయింది మేడం.
ఓల్డ్ బి సెక్షన్ సి సెక్షన్ వాళ్ళు ఎవరు లేరా క్లాస్ లో?
ఉన్నాం మేడం.
ఉన్నాం కదా మేడం. రెస్పాన్స్ మేమే ఇస్తాం కదా మేడం.
ఇది ఒకసారి టర్న్ ఆన్ యువర్ వీడియోస్.
బాగా ఇస్తాను.
అదే సరే మంది కావు.
మా బి సెక్షన్ వాళ్ళు సి సెక్షన్ వాళ్ళు ఎవరు లేరు, ఓన్లీ ఏ సెక్షన్ వాళ్ళే ఉన్నారు.
ఉన్నాం మేడం. సి సెక్షన్
మేము ఉన్నది సి సెక్షన్ కదా మేడం.
మేడం బి సెక్షన్ పర్సెంటేజ్ ఉన్నదా మేడం? ఒక్కనైనా
All are integrated only single session, right? Right. Okay. Now see. So the value represented is, you know, previous fixed point format 5.625 how to represent 101.101, right? But here with floating point any value is represented like this: x equal to minus 1 power s. Here s indicates a sign bit. Okay. So just no need to bother about this. You need to calculate this value 1.f. So just calculate the fractional value. Place that fractional value right side of your implied point. This is the fractional value into 2 power e minus bias. Okay. Now the question is how to calculate the fractional value, exponent value and bias value. For IEEE 754 format, how many bits assigned for exponent? How many bits assigned for exponent? 8, right?
8.
So the value of exponent can be varied from 0 to 255. Okay. The exponent value is
0 to
ranging from 0 to 255. This is the exponent range. So we are taking the maximum value, that is 255 is the exponent value, right? Depending on your number of bits allotted, the value of the exponent will be varied. Is it clear? And similarly, bias value. This is the bias value formula. So for 8 bits, what is the bias value? Tell me 2 power 8 minus 1 minus 1. 2 power 8 minus 1 is 2 power 7, which is 128. Minus 1 is how much? 127. So for 8 bits, the bias value is 127 and the exponent value is 255. Right? So by substituting this value here, you can know the value of the total number. Is it clear? So by using floating point number, you can overcome all the drawbacks which we face with the fixed point format. Right? Now we have one problem. If you done the problem, you are clearly know about this topic. Okay. Now see the question, problem. Just read the problem, all of you. Find the decimal equivalent of the floating point binary number. Observe how many bits are there first, and assume a format similar to IEEE 754 format, in which MSB bit indicates a sign bit, followed by 4 exponent bits, and followed by 8 bits for the fractional part. First, all of you count how many bits are there?
13.
13 bits, right? 13 bits. Among 13 bits, they have mentioned 1 sign bit. Okay, so remaining 4 to 12, right? 4 exponent, okay, and 8 bits for fractional part. So I have indicated with different colors. See, given number is this one. So this green color indicates your sign bit. One sign bit is 1 means what type of number it is?
నెగటివ్
Negative. So the number is negative. Over. Next, what about the fractional part? If I want to calculate the equivalent number, the formula is previous one. This is the formula, x equal to minus 1 power, right? Now, how to calculate the fractional value? So what is the implied point here? This is the implied point here. Are you differentiating this violet color and blue color? Here your implied point is there. Okay, now this part indicates your fractional value, and this 4 bits indicates only this 4. This 4 indicates your exponent value. Now before fractional value, all of you tell what is the bias value. What is the bias value? How many bits allotted for exponent? How many bits are allotted for exponent here?
4.
4, right? How to calculate the bias value? 2 power n minus 1 minus 1. 2 power 4 minus 1, how much? 2 power 3
15.
minus 1. 2 power 3 and 10.
7.
Okay, 8
7,
minus 1.
8.
So bias value is simply 7,
7.
right? And what about the exponent value? Exponent range, tell me first. Value I'll tell.
0 to 255. Yeah.
Right. Not
0
0 to
to
255. Here only 4 bits is assigned, right?
4. Okay.
So 0 to 16. Sorry, 0
0
to
to
15.
15.
0 to 15 is the range. 0 to 15 is the range. But how to calculate the value? See, similar to your integer, it could only binary implied point. How to calculate? 0 into 2 power 0, 1 into 2 power 1, 1 into 2 power 2. Value enta cheppandi? Only these 4 bits indicates the integer, similar to your fixed point only. The value enta? How much?
6, ma'am.
110, what is the equivalent decimal?
6.
6 kada?
6.
So exponent value is 6.
6.
Similarly, calculate the value of this one. Representation is same, but you have to submit these values in the formula. That is different. Ikkada varaku anta same. Tell me what is the fractional value quickly. See, 0 into 2 power minus 1, 0 into 2 power minus 2, 2 power minus 3, so no need to consider this one. 1 into 2 power minus 4 plus 1 into 2 power minus 5 plus 1 into 2 power minus 6. Is it or not? Ante kada? So your value is 2 power minus 4 plus 2 power minus 5 plus 2 power minus 6, right? Now substitute this value in the previous formula. Then you can get the x value, right? See here, sign bit is 1 or 0?
1.
Sign bit 1. 1 means negative number, right? Now substitute
Yes.
values here. Minus 1 power 1. Minus 1 power 1 is what? Minus only, right? That means it represents a negative number. And next 1 point. What is the fractional value you got? I think you got 10.109375. So 1.109375 into 2 power. E value how much? E enta chindi 6 minus bias value how much?
7.
Minus
7.
7, right? That value you need to substitute and multiply this value. E value ni multiply cheyandi, that is the resultant x value, right? In this way you have to calculate the equivalent value of the number. Is it clear?
Yes.
Okay. This is a question where how to calculate the range of numbers. Same. There are total 16 bits. 8 bits are for mantissa. 16 bits are mantissa and 8 bits for exponent. And what is the range of numbers? All of you note down this one, and next class you need to answer this question. You need to take picture or whatever. Just copy this problem. Now make it fast. Note on the problem. Or take screenshot or whatever. Done?
Yes. Yes, ma'am.
Let's see. Now we have.
1 minute ఒకసారి ఇంకా పోరమ్మ.
Okay. Take photo better.
ఫోటో ఇస్తున్నాం మ్యామ్. ఓకే మ్యామ్. ఇప్పుడు దీనికి ఆన్సర్ చెప్పాలా మ్యామ్?
Next class, not now.
ఇప్పుడు చెప్తాం.
వద్దు.
ఓకే.
మీకు అంత ఫాస్ట్ రాదు ఆన్సర్, ఐఎమ్ షూర్. So up to now we have discussed fixed point and floating point. What are the real-time applications? Where we are using this one. Okay.
Mobile TVs.
In mobile TVs and DCT, all image processing is done with the discrete cosine transform. I'll show one example next class. So DCT and video codec. Do you know codec? Coder and encoder. So while coding and encoding video, we are using the DCT. To represent that DCT, we are using fixed point notation. Okay, and in mobile TVs also it is used, representation. And remember, all DSP process supports only fixed point and floating point number format only. Next, block floating point format. See here, just see the question, first question. The following 12-bit binary fractions are to be stored in 8-bit memory. Okay. See, I have 12, see, all of you see here, I am taking 4 numbers which contains 12 bits, but my memory is only 8 bits. Memory need to be stored with only 8 bits, but I have input with 12 bit. How to store these 12 bit with the 8-bit memory? There is a question. Generally what we'll do, and I am saying this is a fractional part. Fractional part means for every number there is a binary implied point is there. So after the binary implied point only your number is represented like this. Now tell me answer how to represent this 12-bit input data to be stored in 8-bit memory. So fractional values generally we are doing, we can neglect the least significant bits. See, total 12 bits are there, right? I want to store only in 8 bits. So I have to discard simply last 4 digits. Just discard because this LSB indicates very, very less value or not. We can neglect the value or not. So that's why simply I am neglecting the last 4 bits. So now see the representation. What is the first value representation? 0, so 111. And second one, 0, so and 4 ones. Third one, fourth one, right? But, okay. But if you denote the numbers with like this format, you will lose the accuracy. Already number is very less. Among that number, you are discarding the value contained bits or not. If you see first number and third number and fourth number, bits is one number of ones is present in the discarded bits or not. So you are losing some accuracy. So that's why we are using block floating point format. So block floating point format is nothing but just observe the given 4 numbers and see is there any logic to store the 8-bit data. All of you observe the bits. Is there any common block? In the common numbers emaina unnaya? Do you have any common numbers? All of you see what is the first 4 numbers?
Starting 4 digits.
Starting 4
Four
digits.
zeros.
Every number is 4 zeros, right? Can I represent these 4 zeros? These are fractions, right? Can I represent into 2 power minus 4?
Yes.
Same the value. మనం 10 power minus 3 రాస్తామా మైక్రోలో నానోలో ఎక్స్ప్రెస్ చేయడానికి. Is it same or not? So this is said to be block floating point format. So if you discard the LSB bits, we lose the accuracy. So that's why we gone for block floating point format in which the common block will be stored separately. So every time you need to call that memory. So now 8 bits memory is enough to store these numbers or not. So this is called block floating point format. This is one more format supported by the DSP process. And see, these are the applications of floating point format. You go through the slide. In military applications, military radar you can use, and in FIR, finite impulse response filters. Okay, wherever you can change the coefficient, then you can apply the floating point format. Right, these are the applications. The last topic, very important in your assessment. Yeah, I'll share you. Don't worry. See, dynamic range and resolution precision. Already you know resolution. We have discussed so many times. A good camera has better resolution and normal camera has very low resolution, right? What resolution represents? The smallest value of the signal, or the smallest value of the pixel represents the resolution. So if you consider n numbers, what is the resolution? 1 by 2 power n. So this is the resolution formula. Note down all of you. So resolution equal to 1 by 2 power n, smallest value of the signal. And similarly, precision is nothing but percentage of resolution. If you multiply this value into 100, that we can say as precision. 1 by 2 power n into 100. That is a precision. So it is related to speed of the DSP implementation. And similarly, dynamic range. What is the range of your signal representation? That will be decided with the dynamic range. So the general definition is maximum value by minimum value. Dynamic range equal to maximum value by minimum value. And here you are note on this point. For every 1 bit, your dynamic range is increasing by 6 decibels. Suppose I say 4 bits are there, 4 into 6, how much? 24. So 24 decibels is the dynamic range of the system. Right? Six dB. For every bit, 6 dB. So these are the dynamic range, resolution and precision. Now see the problem? See the first bit directly. The given format is fixed point format, 24 bit and single precision. So calculate the dynamic range. Already I said for 24 bit, what is the dynamic range? Every time dynamic range is expressed in decibels only. Just multiply with 6 dB. 24 into 6, how much? That is the equivalent dynamic range. And similarly, see the second bit, 48 bit double precision format. So what is the dynamic range? Answer. Dynamic range 48 into 6 dB. That is the equivalent dynamic range. Okay. And what is the precision? Precision is nothing but percentage of resolution. 1 by 2 power n into 100. So for first problem, your answer is 1 by 2 power 24 into 100. Right? That is the precision of the first bit. And for second bit, 1 by 2 power 48 into 100. There is a precision. Is it clear, everyone?
Yes, ma'am.
But the third thing is very somewhat different. Third bit. For floating point, dynamic range equivalent to your exponent value into 6 dB. For 8 bits, what is the exponent value? 255, right? So 255 into 6 dB is the dynamic range. Note down quickly. 255 into 6 dB. And precision is same. So here precision is determined by mantissa. So here precision is 2 power 16, 1 by 2 power 16 into 100. Now note on the formulas. For floating point, dynamic range equal to exponent value into 6 dB. Right? So this completes your class today. I am sharing poll as well as assessment test. Do it now. Is everything clear?
Ma'am.
Okay.
Ma'am, share this PPT, ma'am.
Okay. Definitely. Yeah, answer the questions first. You need to answer quickly. Your next class is ready. వన్స్ అగైన్ గుడ్ మార్నింగ్. అందరు నిద్ర లేచారా?
గుడ్ మార్నింగ్.
క్లాస్ అయితే ఉంటుంది.